Going on now as part of our review in Math 1110, we're going to deal with polynomials and factoring. These are the objectives, and again, much of this was covered in an earlier course, but to review in preparation for what we'll be doing. First, we'll take a look at some of the vocabulary we'll be using here. And first of all, what is a polynomial expression? Well, an expression is a series of terms, and of course in algebra, containing variables, letters. And let's give an example, and they'll be given examples actually below. But the words we want to define is coefficient, degree of a term, the constant part of a term, and the degree of the expression, the polynomial. Now, if there's only one term in a polynomial, we give it a special name called a monomial. If there's if there's two terms, we call it a binomial. And if it's three terms, we call it a trinomial. All others are referred to as a polynomial. We'll use example 1 to illustrate what the terminology we've just gone over. So here, this is an algebraic expression. There's a number 14, which is the coefficient. The variable is x, and it's raised to the 6th power. Now, one term, so this would be a monomial. Its degree is the sum of the exponents on the variable. So here there's just the one variable, so it's 6. Now in example B, we see there is one term, and terms are separated by either a plus or a minus in a series. And then there is the second term. So this is a binomial. And the degree of the first term is the sum of the exponents on the variable. So that would be 6. On the second term, again, the sum of the exponents on the variables. This would be 7. Now, the degree of an expression is the highest degree of any one term. So the degree of this binomial is 7. Now, we also have the coefficient. The coefficient is the numerical part, which in this first term is a -3. And in the second term is, we don't say the positive, if it is positive, 5.4. Now, we often speak of what is called the leading coefficient. Well, the term with the highest degree, no matter where it is considered the leading coefficient and the leading term. Okay, number C here, or letter C. The single number 5, that would be a monomial. There is no variable. We might have thought of that as 5x to the 0 power, where the variable is to the 0 power. So its degree is 0. And again, x, anything to the 0 power is just 1. So this is just the 5. All right, letter D. Now, in this case, as we look at it, this is one term. There's a negative sign. This is one term. This is one term. and this is one term. So there are 4 terms, so we don't give this a special name. This is just a polynomial. Now the degree of each term, here we add the exponents, is 8. Here there's a 1 that we don't write is a 1. This one is 10, and this is 0. So the degree of this expression is 10, the highest degree of any one term. And the coefficient, the leading coefficient, is going to be a 1 that we don't write. So the coefficient of this term is 2/3. The coefficient of this is a -1. Coefficient of this term would just be a 1. We don't say the positive. And this is, we call a constant. As we continue in this example, again, this is one term. This is one term. This is one term. But this expression is not a polynomial because it contains a variable with a negative exponent. That excludes it from being called a polynomial. Now it's still an algebraic expression, but it's just not classified as a polynomial. Now, another variation of this is if we wrote this last term would be 7 over x, bringing that down to make that a positive 1. So exponents that in their simplified form, the variable is in the denominator, that is not a polynomial because it goes under this rule that if we brought it up would be a negative exponent. Now the expression, the square root of x, this would not be considered a polynomial because in its fractional exponential form would be x to the 1/2 power. So exponents in a mathematical algebraic expression that have a fraction are not considered, a fractional exponent are not considered to be a polynomial. So again, lots of vocabulary, lots of words, bringing you hopefully up to speed on algebraic. Now, generally in this course, we're going to be dealing with polynomials. And we did mention what is a leading polynomial or a leading term in a polynomial and the leading coefficient. That would be the coefficient of a term with the highest degree. Our next objective is to look at some basic operations with polynomials. And the first one we'll look at is adding and subtracting and multiplying, and then beyond that we'll go to factoring, which is the last portion of this. But I'm not going to spend a lot of time on this. The key thing here is like terms. So a little background on what are like terms. Well, if we have 2xy minus 5xy, these are like terms because the variable part, that is the algebraic letters and exponents, are the same. Now, if the order is reversed, yx, that's still a like term. So part of what we need to do here is to figure out what are my like terms. So looking at this, I'm just going to write out what I have here. Now I put a 1 there to help with calculations, but normally if it's a 1 you don't write it. So now I'm looking for which like term column. A 3y goes here as a positive 3y. Z to the second. Well, there is no z to the second. So I create a new column, z to the second. Now a negative 3x z squared. Now notice I said you could reverse this. So this would actually go here, a negative 3x z squared. Even though the letters are reversed, this is still considered a like term. And then we have a plus 4, which doesn't match up with anything. So we just add them all up. So this is 2x to the third y. Now, interestingly, these just cancel out. Now, since we have a positive 1 of these and a negative 3 of these, this will give me a negative 2x z squared plus z squared plus 4. And there's my answer. All right, now going on to the subtraction. It's done in a similar way, but there's one important point. Let me write it. 4ab cubed minus, and again, we can put a 1 there, b to the third c. Now, whenever we have a negative sign in front of a parenthesis, the protocol is just to remove the parenthesis and change each of the signs. So where this is a positive 4, this will become a negative 4 out here. Now my negative b to the third c is going to become a positive b to the third c. So I put it under this column. Now notice these will cancel out, and my answer here is 4a b to the third minus 4. Okay. Again, some may prefer to do it horizontally. I like the idea of doing it vertically, where we can really see the like terms lining up. Let's go on. Now, in example 3, we're going to do multiplication. So the protocol for this is to take the first term here and multiply it by this term, and this term. Then take this term, multiply it by this, and by this, and you get a string of numbers, and then you're just going to group your like terms. Now, another way of doing this would be to put the top row, 4 plus 3z minus 3xy, and then put this underneath it, 2x squared y minus z to the third, and then do it vertically and try to line up your like columns. And moving down, we see them doing it horizontally. Again, I'm not going to write all of this. In your notes, of course, you want to have this practice. So B is done in a similar way, and we're distributing and then combining like terms. Pause if needed. Okay, we're going now to the FOIL method, and we'll use the whiteboard for this, and I'm going to write out the example. This is example 4, but we'll go to the whiteboard. So FOIL is just the method of doing what we've done already, distributing, and here's the process. The F now stands for the first items in each of the sets of parentheses. So we're going to multiply this. This will give us 3a squared b squared. Multiplying this times this, keeping in mind we're just adding these exponents. Now the O stands for the outers. in this arrangement. So we're going to get a positive 3, a to the third, b. So checking it, a times 1 is, or 3 times 1 is 3, a to the first, a to the second, a to the third, b. Now the I stands for the inners, and that'll be a negative a to the third, b. And the L stands for the last in each of the parentheses, and that's going to be a negative a to the fourth. Now notice in the middle you happen to have like terms. Remember there's a 1 there that we don't write, but you can put it there for calculation. So we have 3a squared b squared. Now when we join these we get a positive 2 a to the third b and a negative a to the fourth. This is a result of FOIL and is a super useful tool as we do factoring later on. All right, let's go back to our regular board and we can check our answer down here and we have it correct. Now our next background item is special products. And these special products are things that if we can recognize them in the future help us with factoring as well. Now here we see A, B as binomial, and one's a positive and one's a negative. So we say when we multiply the product of the same terms, one's the sum, one's the difference, we get a special product called the difference of squares, or sometimes referred to as the difference of perfect squares. Now let's give you an example here. A plus B, A minus B. So foiling it, we get A squared. Outers, a negative AB. Inners, a positive AB. Last, a negative B squared. Notice what happens to your middle terms. They cancel out. So we're left then with just A squared minus B squared. We say that's the difference of perfect squares. Difference of perfect squares factors into this. And you may recall we said in an earlier lesson, these are called conjugates. So let's write that word down again. So factoring the difference of perfect squares factors into their conjugates. What are conjugates? The terms are the same, but one's plus and one's minus. Okay, the other special product that we have is this one, where we are squaring a binomial. One with a plus, one with a minus. Now it works out the same way. Let's do one. A plus B, the quantity squared. The special way of doing this is squaring the first term. That gives you A squared. Now you multiply these two together and then double it. And that gives you 2 plus 2AB. And you square the last term. Now this has a special name. And I'll write it down for you. It's called a perfect square trinomial. When we have a perfect square trinomial, it will factor into a binomial that's squared. This is going to be a useful thing coming in the future. Now, the only thing different between line 2 and line 3 here is whatever term is in the middle, the sign, that's the sign of the trinomial. So here it's positive, here it's negative. Otherwise, everything is exactly the same. Now let's just do an example of one of these. We're asked to square this. So this will become 2x squared is, or 2x squared is 4x squared. Now we're going to multiply these two together. We get a negative 2xy, double it. That gives us a 4xy. And then we square a negative y, gives us a y squared. Now, notice in letter B here, we've done some of these before when we were rationalizing the denominator in a previous lesson. These are conjugates, and the special name, they're radical conjugates, where part of it is a radical. So again, in using the FOIL, we just do the outers. We do the first and then the last, and it's going to be the difference of squares. But this becomes the square root of y squared, which is, I should say, x squared. That just becomes an x, and this one's the y squared. This just becomes a y. And again, we've done this before, so hopefully a quick review. Let's go on. Now we're going to take a look at the greatest common factor, but we need to look at, in general, this concept of factoring. So if we have a trinomial, which is a product that came from foiling two binomials, there ought to be a method to go from this back to this, and that's what we're going to look at here. Okay, and we'll go through this in some detail. Now, we want to be sure you are familiar with the protocol for getting answers and vocabulary that they're using. This is example 6, letter A, and there is the expression. So what they did is they teased each of these apart and found that they each had a factor of 4x squared. So then they took the 4x squared out of each term, and then taking that 4x squared out of each, and then writing it in a fashion like so. Keeping in mind that here, this negative 1, in order to get this as a negative 4x squared as this middle term here. Now, this is factoring out the greatest common factor, and it's the result of the distribution of this initially. Now we are factoring. So in example B, and I'll clear this up so we don't get too confused here, we're taking out of each of these two terms a negative 12a. So then what we're left with is a negative 12a on the outside, and then on the inside 2x squared plus, well, in this case it's just going to be a negative 5 here. Yes. Again, I could go over it in great detail, but that just lengthens what we're doing, and these tend to be a little long, and I want to try to keep them short if I can. Now, for example, C here, as we study it, we see we have this binomial, which is the common factor. And there's actually like a 1 in front of that we don't write. So what we're going to do is if we were to factor this, we would go 1 and the minus 3 times a to the second minus b. Now they're showing it as a little different way here. I'm not sure quite what they're looking for, but this is how you would factor this. And this would become then a negative 2 times that, and that would be simplified, but they're not taking it that far. They're just showing it this far, where you'd factored out a 1 and a negative 3 here. Okay. Oh yeah, there it is down here. That's where it is. Okay, so this is then a squared minus b. I should look a little further down. All right. Now for this one's kind of sophisticated because they're dividing this up into this binomial is to the third power. So they're writing it out as 1 to the second power, 1 to the first power, and then 3 times this to the second power. And was a little challenging how to pick out what they ended up with. So what I did is I rewrote it here. So there's your common factor that's found in both. So I wrote that here. And then there's what's left over. There's this and this. So this and this. And then they just took away the parentheses here. Let's get my eraser going. To get that, which is in a parenthesis there. Okay. Again, some challenging material. Now, for example 7, we're going to factor by grouping, and usually it's in a 4-term sequence where there is no common factor for everything. But if you rework this, and let's go to the whiteboard, we look for what kind of combination can we move them to get common factors. So if I put, let's say, 6x squared plus 2x, bring this over, and then this is going to be a negative y and a negative 3xy. I may get some common factors. In fact, what I'm going to do is take this 2x and put it out here as I look at that a little better here. Okay, so it's the same. I've just rearranged things. And often, not too often, but sometimes it does take this. You need to look at it, make some judgments, and see if you can do it. So what can I take out of each of these terms here? Well, I can take out a 2x. So here I'm left with a 1 plus 3x. Ah. Now, as I look at my next two terms, I can take out a y, but the signs are wrong. But if I take out a negative 1y, remember we're not going to write that one later, then this then becomes a 1 here plus 3x. Ah. So now we have a common binomial factor, and we could write that first, or we could write the 2x minus y. Again, the final answer, you don't put the 1 there. And then the 1 plus 3x, factoring that first one by grouping. Let's check it out here. And I think we have to go down a little bit. They have it in a different order here. but essentially it's the same. Okay, let's go on to item B. Now for item B, we didn't have to rearrange things. They were 4 terms, and we took an A out of the first two, and again a negative B out of the second two to reverse the signs, and then they do it x minus y, and then A minus B. I tend to put these first, but it's fully acceptable either way. All right, let's go on to C. This one is straightforward, so we'll just follow what the book is showing. But here we see there is a common factor in each term, so that you factor out the x. And then using brackets here, they will take out a common 2 from the first two, a negative x squared from the next two, and then putting the x there, bringing these two together, and then writing it in its final form. I think this is straightforward and can just copy it into your notes. Pause as needed. Now, earlier, they had special products where we are factoring the difference of perfect squares will factor into their conjugates. Now, there's also a difference of perfect cubes that factors into something that I will go over with you shortly, because we didn't do that. And then the sum of 2 cubes. And then we're also going to later factor perfect square trinomials into their binomial squares. So the difference of cubes and the sum of cubes factor in a certain way that there's a recipe to follow, and I will spend a little bit of time doing that. All right, let's go on to example 8. Now, this one, it's nice to have something a little easy. We recognize this is a perfect square, this is a perfect square. It's the difference of perfect squares will factor into its conjugates. So this is going to be a 7x, a 7x. We just need the first and the last. Now this is going to be a 3y to the third and a 3y to the third, and one will be plus and one will be minus. And I think they have that one. We can actually see it right there. Now these others are special factors of the sum of cubes, the difference of cubes. Now B and C are sort of straightforward. D, because it's a binomial, is a little tricky, and I'll do each one of these in some detail using the whiteboard and go over the recipe as well. Now, whether it's the sum of cubes or the difference of cubes, it works the same way. And I'll take time to do this with you. So for instance, this is a cube, this is a cube, this is a cube, and this is a cube here. I've got to that. There we go. Now, what's the protocol for factoring the sum of cubes? Again, the difference of cubes is done the very same way. Well, you put a parenthesis for 2 terms and a parenthesis for 3 terms. Now, whatever sign is there, this is the sign that goes here. And whatever sign goes there, the opposite sign goes there. So this is part of the recipe, and You just have to know this. Now, you take the cube root of this and the cube root of that. Now, the cube root of this, and we had this earlier, is going to be 3, and just divide the 6 by 3 and you get 2. Divide the b to the 12th by 3 here and you get 4. And then the cube root of c to the third is just plain c. All right, so you have that factor, this binomial factor. Now, what do you do next? You then square this term, which is now going to be 9, a to the 4th, b to the 8th. Now you multiply these two terms together, and you get 3, a to the 2nd, b to the 4th, c. And then you square this term. And that is the protocol for doing this example, which is the sum of perfect cubes. Now, if you're doing the difference of cubes, the only difference is this sign will be negative and this sign will be positive. So let's go back to our whiteboard and from our whiteboard and take a look. And we'll pause here. So it was a little confusing as to where the answer was, but here it is here. There's that. And there's the answer right down there. Now they are showing us the recipe, but I'll show it again on letter C. This was the sum of perfect cubes. We're now going to do the difference of perfect cubes. Okay, I just copied it, and then we'll go through the recipe on the whiteboard. So again, how does the recipe start? Well, you need a parenthesis for 2 terms, a parenthesis for 3 terms. Now, whatever sign is there goes here. And whatever sign is here, the opposite sign goes there. Now, you take the cube root of both of these. Now, the cube root of 125 is 5. The cube root of y to the third is y. Now, the cube root of a negative 8 is a negative 2c. So that's the first step after you set up your parentheses and get your signs. Now, you square this term. That's going to be 25y squared. You multiply these together and get 10yz. And you might say, well, wait a minute, shouldn't that be the opposite sign? Well, you disregard that for now. You're just multiplying the terms, not caring about the sign, because you've determined what that sign should be. And now you square this term. And squaring a term is always going to be positive. So 4z squared. Let's go back to the board and check out our answer here. And we can't see it, so let's bring it up a little. So there it is, 5y minus 2z and 25y squared plus 10yz plus 4z squared. Perfect. Now, the key to this is, if you're not sure, you can watch it again. That's the good deal. Let's go on. Okay, there's letter D now. and it's written out here, but we'll work it on the whiteboard for you. So again, the protocol is parenthesis for 2, parenthesis for 3. Whatever term sign is there, goes there, and the opposite goes there. Now the same protocol follows. What's the cube root of this? Well, the cube root of 64 is 4. And the cube root of this, taking a cube root, just becomes this radicand, which is going to be a negative x plus y. This is the tricky part here. Okay, now for this one, it's going to be this squared, which is 16. Now it's going to be 4 times this, and let me put my sign here a little better. It'll be 4 times this, again disregarding that x plus 4. And then we have to square this. So this is going to be plus x plus y, the quantity squared. So we have to clear parentheses now. They're using brackets in the other. That's good. So this then becomes 4 minus x minus y, I believe. And yes, I checked that. And then this is 16 plus 4x plus 4y. And then we have to expand this. We square the first term, x squared. Multiply these two together and double it, plus 2xy. Square this term, y squared. And that is the factorization of this one, which is a little bit complex, as you can see, but there are no like terms here that we can group together. So again, a challenge, and once again, you can always watch it again. Let's go to the screen and see it here. Yes, there it is. Wow. All right, let's keep moving on. There's just a few more to go. This will be a little shorter than some of our others. We're now going into the actual factoring of trinomials that we foiled and worked on earlier. There is a protocol, but I'll go over that as we... Now, for example 9, they're starting us off with a nice, easy one. But let's go to the whiteboard to see it. So remember, this was a product of 2 binomial factors. So what's the protocol? Well, have it in standard form. And remember, standard form is ax squared plus bx plus c, where our a value that we'll speak of from time to time is a 1. Our b value that we'll speak about is a 1 here, and our c value is a negative 12. So we say, is there a common factor that we could take out of each one? No. Then the protocol would be to put 2 sets of parentheses because you're hoping that this will factor into 2 binomial factors. Now your a term here is 1, so the only possibility that could go in as we undo the FOIL is an x and an x for the first term. Now we look at the c term, which is a negative 12. Well, what factors of a negative 12, when we multiply them together, would add up to a positive 1. And we could mentally do this. We go 1 times 12. No, that's nowhere near a 1 for a difference. 2 times 6. No, that's going to give us, here would give us an 11. This would give us a 4 difference. And 3 times 4, wait a minute now, 3 times 4, let's try that. A 4 and a 3, you could put them in either place. And now when we multiply them, we get a 12, but we're looking for a negative 12. So that means one of these must be plus, one's positive, and one negative. So which is which? Well, when we do our outers, we want to get a positive 4, so that when we do our inners, we get a negative 3 to add up to a positive 1. So this is going to be a positive, and this will be a negative. And then you check it by FOIL, and you get this. And that is the answer. So let's go back, and there it is, right there. Okay. Now, here in the factoring process, they're introducing a method that's called the AC method. That is, when your A value is not a 1, this could be an alternative. And I'll go through the details with you. So looking at our example, they're going through this, and I will use the whiteboard for it. So in the AC method, which eventually results in factoring by grouping, you want to first see that it's in standard form. There it is. There's no common factors. And they're asked to use the AC method. Well, what is A in this expression? Well, A is 6, and B is a negative 12. So you are to multiply the A times the C, and that gives you AC equals a negative 72. Now you're going to look for factors of 72 that have a difference of 1 here. So 1 will be positive, 1 will be negative. And as I look through that, I know 8 times 9 is 72. And if I wanted to get a negative 1 as a middle term for my B value, the 9 would have to be negative, the 8 would have to be positive. So I'm going to rewrite this into a 4-termed expression. And it's going to be 6x squared. That part stays the same. But I'm going to take my 8 that I said was positive, 8x. Now I'm going to write my 9, which I said was negative, 9x. And then my C term stays the same. So this expression and this expression are the same, except in the top one, we collected like terms. And in the bottom one, we separated our B value into 2 factors that result in the B factor. But now I have a 4-termed expression. I'm going to factor this by grouping now. So out of here, I can take a 2x, and then I get a 3x plus 4. Now out of here, I'm going to take a negative 3, and I get now a 3x plus 4. Oh, that little trick of taking a negative out, that will reverse the signs. Now I go 2x minus 3 in one set of parentheses, or I could have written this one first, 3x plus 4, and I have factored this by grouping using the AC method that they're describing here. And I'm going to go back to our regular board, and there we see it. In fact, they've written it the same way that I would have written it. Oh, good. All right. If you have these two binomials reversed, that's still okay. Now, for example, 11 here, and we're almost finished. Just one more after this. We are going to look at factoring a perfect square trinomial. Well, first of all, recognizing one. Well, your first term's a perfect square. Your last term's a perfect square, and they're always a plus and a plus. While your b term is the product of the square root of this, which is x, times the square root of that, which is 5, that's doubled, and this meets the criteria. So in factoring it, and again, you can do the traditional way, or if you recognize it, you can just do the end thing. And this would be an x here, an x there, a 5 there, a 5 there. Middle sign is plus. This is going to become x plus 5, the quantity squared. Okay, so hopefully something easy. Now, if this middle term were negative, this would be negative, negative, and this would be negative. All right, let's go on. Now, for this last topic, here we're going to be factoring expressions containing fractional rational exponents, and they're just not integers. And we'll use what the book is showing us because they do a good job too. There's just two examples. This is our last slide here. So let's see if we can follow what is written. So there is our trinomial, our first one right there. Let's use this one here. So is there a common factor in each one? And the answer is yes. You could factor out of each one of these, and it's dealing with fractions. 3x, and then the x is to the negative 2/3 power. Now when you do that, you get this. And then we are rearranging this to this. And then this is just the simple factorization. This is a perfect square trinomial that they're then writing as this. So save time, pause, look at it, and interestingly on these, they do give you an explanation of what's going on. In example B, it's again a little bit tricky. They're going to factor out this from each term and to get a second factor, which is then a -1, and then summarizing it in this fashion. I'm not sure we're going to be using much of this in this course. It's shown here, but this will wind up our lesson. Just a tad shorter than others. I thought it would be a lot shorter, but didn't work out that way. Okay, lots of stuff, lots of review, and good luck.